Okay, so we just finished the midterm, got our results back, and very interesting. I personally found the midterm to be a bit, it was a little cheap, I think. The questions were like almost literally right from the textbook. I was hoping for something more interesting, right? A little bit more like application based, but maybe that's reserved for like second year or third year. So I guess I have to wait a little patiently. But I looked at both questions from Maria, who happens to be my instructor, and there's another Indian guy that I cannot memorize his name. I go to his tutorial, so a bit sad. But I also have his quiz, and I do not have the quiz from Carlos. I'd imagine his test might be a little bit harder, especially since I get most of the help from Carlos. My schedule's really messed up. So I have a professor who happens to be Maria, but I go to tutorial, which happens to be that Indian guy, and I get like, individual help from Carlos. So yeah, it really messed up. I wish my schedule was a little bit more, more workable for next semester and on. But it's fun. It's nice being busy. Amongst with other things. So anyway, so without ado, I'm gonna just go through these midterms. Some of you may be interested, but this is really mostly for future students who are preparing for a midterm, and if they finish out the practice question, they might say, well, I want some test like practice tests. So and I'm pretty sure they're gonna be like rewriting the quiz every year. So so this might be a great opportunity for them to get a little heads up. It's kind of privilege that we are here that don't necessarily have, but who cares? Anywho, so this is the solution that this is a question that I wrote down. Basically, you are solving the linear equation using Gauss-Jordan Elimination method. So maybe I should write that down if you guys forget. Gauss-Jordan Elimination. Whoa, like that. Yeah. So it might be better if I post this. Yeah, that was an oversight. Yeah. Right. Yeah. Okay. Whatever. This is my format, so we're sticking with it. If you want to try doing this without doing the solutions, I will in the future post a link with a typed question with no solution, so that you guys can take a get a chance to do it, and then after you're all done, then if you want to take a peek, take a look at this video. Anyways, so this is for the Indian guy. So interesting. But anyways, so this is the first question, and so I already took the liberty of putting it into a matrix format, which isn't hard, right? Just x, y, and z. Oversight, that's not x, that's z. Okay, so yeah, z and then some coefficients, right? So there's going to be 3 unknowns and 1, constant. So x, y, z, so that's 3. So I just, so that's going to be x, 2, no z, right? So that's going to be 1, 2, and because there's no z, it's going to be 0. Let's look at this one. It's going to be 2x, y, and 6z. So x goes here, right? So 2. So nothing means 1, right? Right? That's implied, right? 1 times anything is the same thing. So 1 goes there, and 6z, and so 6 coefficient goes there. I mean, this is just a quick review. You should know this by now. If you don't, huge trouble. This is like 1.1, review, right? So, and 1 and so forth. So I just made this matrices, right? So, what is the tricks that you could use? Well, if you've done enough practice questions on section 1.2, this should be instinctive, right? Almost like allergic reaction. Like you should look at this as like, wait, I don't like this. Because if I'm trying to do elimination, well, let's see here. It could be anything. I would just choose this one because it already set up, so you don't have to go through divisions. Like if I wanted to make this 1, I could, but this will be half, 3, half. Generally, I try to avoid fraction if possible. Ultimately, it shouldn't matter. You should get the same thing, but nonetheless, right? -1, you could do that. You could make it as 1, -1, 6, 2, and then use that as a row. But then you have to do negative times the third row, and then you have to switch the third row to first row. So why bother all the hassle, right? We don't get additional points for making the steps longer. It's actually quite discouraged, especially, considering our field, right? So because of that, I will choose this one, right? To be so that this will be the leading coefficient for the column 1. So that means he has to get rid of all the competition. And if you remember the row echelon form, right? So below and above 1, there should be only zeros. There should be no competitions whatsoever. So my first goal, get rid of all these so that 1 is the only last man. He's the last man standing. All right. So what I don't know. I might be running out of yes. I'm doing this at home, so the blackboard isn't not blackboard. What am I saying? Whiteboard isn't exactly the best I have, but you know we're going with it. Okay. So row 1. Oh, and unlike other videos, I'm switching from using line 1, line 2 to row 1, row 2. That's technically a better term and more precise terms. I got scolded a lot, not necessarily because I got the wrong answer, because I used those notations. So if I caused you some grief, my bad. But you know, now you know, right? We learn from our tests, right? So R1, so it stays the same, right? But we're going to be using R1 to get rid of everything. So 1, 2. Well, 2, so it's going to be, so first it's going to be 0 for sure. It has to. How do I make 1 and 2 add it together so it becomes 0? So what I'm going to do is negative R2, right? Negative R2 plus R2 equals R2. So that's all I'm going to do. Negative 2, 1, negative 2 cancels out. Beautiful. Negative 2, negative 2, negative 4 plus 1, negative 3. Okay, and 0 times anything is 0, so whatever. So plus 6, right? Because 0 times anything is 0, plus R2, 6 is already there, so it's just 6. Negative 2 times negative 1, 2, plus 1 is 3, right? So I'm trying to review a little bit, but this should be like second nature by now, right? If not, look at 1.2 again, right? So again, this, I can just add them together to become 0, so it's 0. So I'm just going to add, yeah, I have to remind myself. I sometimes don't do this consistently. R1 plus R3 will give me R3. So if that's the case, then that's going to be 0, 2, 1 is 3, negative 6, and negative 3. Okay, so that's good. Now, I'm just going to constantly raise this because I have no other room. Like normally, I would like tilt the camera up to the side, but again, this is a small whiteboard. I mean, you know, so, you know, this is as big as my sister wanted, so unfortunately we're going with it, okay? So, maybe we can erase this now. Okay, so, the order is going to confuse you a little bit, but whatever, okay? We're going up, down, right? So, so from this one, now we're gonna say, well, okay, so first, a leading coefficient, no competition, beautiful. Let's look at the next one. Okay, which one should I choose as a leading coefficient? This can't be, right? Because we have a leading coefficient here. So he is already out. He already won once, right? You know, stop spoiling the game. Let other people win, right? So we can choose this guy or this guy. And it's really up to you. But the one thing I noticed, interestingly, this is what I would totally do. 363, say 363, right? So, you know, they're all factors of 3. So how about we simplify the number a little bit? And that might be actually a lot easier. So, before elimination, I'm actually going to do just that right away. So that's going to be negative 1, negative 2, and 1, 0, 1, negative 2, negative 1. Where did all this come from? And this will explain why. R2, what it was divided by 3, gives me the new R2. 1/3 R3 equals to R3. So all I did was from these 3 numbers, I just divide everything by 3. And obviously for 0, it doesn't really matter anyway. Oh, crap. Okay. Yeah, no, you can see it. Okay. So yeah, so that's the idea, right? Now, and you can see why I did that, right? The leading coefficient is already 1. So, you know, it seems pretty simple to start with this and get rid of everything. Sort of like what we did before, right? So what I do, so we're using this, so this row will stay the same. Right? So we're going to use row 3 to eliminate others. So that's going to be 0. I'm just going to add them to become 0, right? Minus 1, 1. Okay, and I'm going to add these, which also happens to be 0. Ooh, interesting. 1, negative 1 is going to be 0. Okay? And so let's I'll tell you why it's interesting a little bit. You should know, right? This second row tells us something because they're all zeros. But anyways, 1 doesn't get affected because it's 0. It's 0 right there. 2, how do I get rid of that? I'm gonna do negative 2 R3 plus R1 equals to new R1. So if that's the case, this gets deleted. Negative 2 times negative 2 is 4. 4 negative times 2, negative 1, 1. Okay, interesting though. Yeah. So, so that's that. We have a 0 equals 0. So the system's gonna be what? It's gonna be infinite solutions, right? Unless these somehow cancel so that we have inconsistency. But I highly doubt it because it has a leading coefficient, D has a leading coefficient. So chances are we're not gonna get another one that's like 0 equals to some number. So, but yeah, so are we done? Well, let's see. Technically this is done because we have a leading coefficient here, we have a leading coefficient here. This guy's no leading coefficient, so there's no other leading coefficient we need to isolate. But remember, this is technically echelon form, right? So what was another rule about echelon form? All non-zero rows have to be on the top. All the rows with zeros should be at the bottom. Which means, even though number-wise this is technically correct, it is not in reduced form. And remember, the question was asking using you have to use Gaussian or Gauss-Jordan elimination, right? So I think either way, whether you use Gauss or Gauss-Jordan, you're gonna have to move this. So you're gonna actually have to do this: 1 0 4 1 0 1 negative 2 negative 1 0 0 0 0. And just mention like R2 and R3 are flipped, right? Or what else? What other things you could have done is when you have this, maybe like use this as a reference so that you don't have to move it. But ultimately, it doesn't matter, right? Another thing, we mostly like Gauss-Jordan elimination because the leading coefficient simplifies, so usually it's an easier number to deal with. But ultimately, it really shouldn't matter because the question was solve a given system of equation using either Gaussian or Gauss-Jordan elimination. So Gaussian just means any echelon form. It doesn't have to be reduced, which means leading coefficient doesn't have to be 1. It could be 2, 3, or whatever, right? So as long as there is only one leading coefficient. So let's say there was 2 here, right? It's not reduced, but it still works because there's no other competitor. So again, I would let you go back to the rules that we heavily discussed in 1.2. So, but yeah, this is ultimately how you get the answer. We're not quite done, but we're almost done. Okay, so you have R2 and R3, right? So this is a reduced form. So we're gonna translate this into a linear equation. So that's gonna be first one. So that's gonna be can't write too high. X no, 0. So we're gonna have, so we're just simply translating the matrix back to the linear equation, right? So we have to just figure out what x and y and z are. Well, infinite solution implies that we're gonna have some kind of a parameter, right? Which means, well, let's look, y and z. Well, they're both unknown, right? So, we have to choose one and then set it as a parameter, because, it's an infinite solution. It could be anything, right? So I'm just gonna go like y equals 2 to z. I just move this to the other side, minus 1, because there's minus 1 here, right? So here I just want to find out y using z, right? It doesn't matter. You could do the other way if you prefer, right? But I'm just gonna choose z. So z is gonna be a parameter. I don't like to use the word p because p sounds like it is it's an initial parameter, but it ultimately doesn't matter. Try to just avoid using x, y, z or like other untypically other constants that we use typically as an unknown variable. So maybe this is what I use, right? I use macro, like I don't know, as an example, right? And macro is real number, right? So if that's the case, then we could say y equals to 2 macro minus 1. Okay? And x is going to be, x is equal to, I'm just going to move the 4z, so it's going to be 1 minus 4z. Well, we already defined z as a macro, so it's going to be 1 minus 4 macro, right? So now that we know the x, we know the y, we know the z. So I mean, technically you could leave it like this, but I think many of the professors, they appreciate if you organize your answer. So so what we're gonna do is z. So it's gonna be, let's say, let's make it a little fancy. X, y, z, just like a matrix, right? Equals to, x was what? Did I erase it? Yeah, 1 minus 4u, and then y was 2u minus 1, and z was u. And then technically you could say z equals u, and it's a real number. Right? So, yeah, that's what I would do. Now, this person who has happened to loan me this test, I can't say who, happens to got this all right, but I would, if I was a prof, because I'm just a jerk, right? So don't take it personally, or did I say he or she? Okay, it could be he or she, okay? If I messed it up, right? But this person said let z equal to s, right? But you S is a real number, technically. Yeah, well, kind of hard to argue with someone who got a better mark than me, but oh, come on, I got it all right too. I just made a really stupid mistake, and with the elimination process, and unfortunately, that mistake was very costly. So, oh well, I just need to get an A, so it doesn't really matter. But still, I should have got 100, but whatever. This video is not about stroking my ego. So, okay, moving on. Find out. Okay, so let's see. So this is the second question. X plus y plus 2z equals to 1. X plus 2y minus z was k, and 2x plus 2y plus k squared z gives you k plus 4. Okay. And the question is, find the value of constant k in which the following system has unique solution, no solution, or an infinite means. Okay, so good. So you're gonna give this, and you're gonna do the same thing. Finding the linear, put in matrices, simplify as far as possible, bring it back to the linear equation, and then solve for x, y, and z. But as you can tell, how do we know this has a lot of different solutions? So we're gonna, because there's three unknowns, and three columns. So is there any free variable? No, right? So that's why we can tell, we can solve this question. But anyways, so because of that, so exactly what I said, and then when we reduce it simply enough to the point where we can look for solutions, we get to choose. Because the chances are there's multiple ways to solve this question because of the k, right? But anyways, so same thing. I'm gonna put it in matrix form. 1, 1, 2, 1, 1. That's negative z, right? Yeah. Minus 1, 2, 2, k squared, k plus 4. This is cheating, seriously. This is almost exactly the same question as the textbook. Like they just removed k. They just replaced a with k. I mean, not that I would, okay, I don't know why I'm complaining about this. Okay, sorry, okay. Why complain when the questions are easy, right? But anyways, so this is a matrix that you're given with. And again, you do the same elimination process. And then what you do is, well, this is simple. So I'm just going to choose this guy. Again, you could choose this. I would avoid choosing this, because if you do that, it's going to be k squared divided by 2. That's going to be really messy. So, let's try to avoid fraction if possible, right? So how far can I go down? I'm gonna combine this video. Okay, so 1, 1, 2, 1, 0, 1, negative 3, k minus 1, 0, 0, k squared minus 4, k plus 2. How did this happen? Well, so I'm using row 1 like I said, right? So row 1, and how did I get rid of this? Minus plus R2 gives me new R2, and then I'm gonna have R2 minus 2 plus R3 equals to R3. Yeah, like I said, review 1.2, but negative 2 to get rid of that 2 over there, and negative 1 to get rid of that 1 that used to be there, right? So this looks pretty simplified to me. Why? Leading coefficient here, and yeah, really messy, but leading coefficient there as well. You can see everything. Good. So because of that, yeah. So this is as far as we can go, right? I mean, this is unknown, so we don't want to touch too much of that. We have to try to figure out how does k squared minus 4 eliminate negative 3. No, that's not the whole point, right? So now the point is this. So it seems like this is the guy who's going to determine, right? Because there's going to be something z equals to some number. Remember, that was the time when we discussed with 0 equals 0 and 0 equals to some number, right? Where the 0 is not the constant. It's like okay, this is, I can see why they don't write it this way. So it's going to be 0x plus 0y plus 0z gives you some number, not 0, right? And then anything else, anything that doesn't apply this or this will be a unique solution. So we talked about it in 1.2. So I'm not going to review it again. That will make this video too long. Some people already mentioned that to me directly. So yeah, by the way, it's not going to get short anytime soon. But still, I can try, right? So anyway, so I'm going to make it k2, 4, minus 4, and k plus 2. Because these are the two that really matters. Now, let's start with our easy one. Infinite solutions. In infinite solutions, 0 has to equal 0. Okay, so this just means, okay, how do I make k squared minus 4 equals 0 and k plus 2 equal to 0? Well, let's see. That's going to be just k plus 2, k minus 2. This is just factoring. If you don't know how to factor, please review. I plan to do, post pre-calculus video solutions as well, but not anytime soon. And hopefully everyone's comfortable with this already. And then you have k plus 2. So I want to make this to become 0. What are the possibilities? K is either plus or minus 2, right? This one's going to be k equals to negative 2, not plus, because if you do 2 plus 2, that's going to be 4, right? Okay, so in this case, when could it be 0 equals 0, right? So if I use 2, not going to work, because if I put 2 here, yes, it's 0, but this one won't be 0. But interesting, I know we're solving for 0 equals 0, but we could just say, wait a minute, so, I have some number here, I can make 0 here, but equals to some number. That was an inconsistent one, right? So no 0 is equals to some kind of constant number, right? Which is not 0, where this is not 0, right? So because of that, we can automatically say, when k equals to 2, it gives you inconsistency. Right? Now, however, if we were to go back to this problem, well, when are they both the same? When it's negative 2. If this is negative 2, 0. If this is negative 2, it's 0. 0 equals 0. So when k equals negative 2, is infinite solution. And this is inconsistent, or no solution. So, what about unique solutions? And that's where it gets fun, because anything that's not inconsistent or provide infinite solutions, they're all unique solutions, right? So, and we talked about this 1.2 again. I know I'm repeating a lot, but I'm trying to be like a lawyer, explain all the stuff along the way. So anything that is not k, so k that is not plus or minus 2, unique solution. Unique solution, right? So that's what you should have said, right? And this person did exactly that. Beautiful. Yeah. So he wrote some weird things. He actually explained this rule. Yeah. So okay. I guess it's sort of implied that you know that, but I guess explaining that doesn't really hurt. Okay. Fair enough. But anyways, yeah, that's how you would do it. Okay, so third question, find all values of k, if any, that satisfy the following matrix question. This Indian guy really loves a constant k. But anyway, yeah, 2k. I promise for the other solutions manuals, 1.5, 1.6, and so on, they will be posted on a better whiteboard when I'm actually in school. Yeah, you guys can see. I wish I had this question. This is I just love how like matrices with different dimensions can somehow like all shrink down to one. This might be very cool concept we can implement on like future future programmers. But yeah, that's a distant time in the future. So anywho, so how do we make the 0? Well, this is 1 by 3, right? Row first, right? 3 by 3, and this is 3 by 1. Well, I mean, it already gives you a pretty good prophecy, right? If you times this by this, it's going to be 1 times 3. Remember, this cancels out. And then you times it by this, so this cancels out. So it's going to be 1 by 1, which happens to be 1 entry, right? So, yeah, so I totally buy this. But that's not what it's asking. It's asking what has to be the K solution. Well, let's give that a shot. Okay, so I'm just going to multiply this first, right? So this first, right? So again, this is the 3 rule that I love to use. Now if you have 4, then you might have to do this, but anyways. So I just go like, because I'm a visual learner, so I just go like this, and then go like that, and everything that I'm timesing must be a sum. So what I mean by it, so 2 times 1 is 2, 2 times 2 is 4, K times 0 is 0, so it's going to be 2 plus 4 plus 0, which is going to be 2, 4, 6. Okay, so next one's going to be same thing. So 2 times 2 is 4, 0, oh, K plus 3. Okay, oh, no, 3K, you're timing it, yeah. So it's going to be 3K plus 4. Okay, and then next one's going to be 0, 6K, K plus 6. 2K. So that's what you would get, right? Okay, so again, then we just do the same thing. We can times it because it's 1 by 3 and this is 3 by 1, so dimension it makes sense. Gonna do that. So it's gonna be 6. So it's gonna be 6 times 2. It's gonna be 12 plus this times that is gonna be 2 times 3K plus 4. And then plus, there's going to be K plus 6. That will give you 0. And the rest is just algebra, right? We just isolate for K, and yeah. And then, you know, hopefully that K, you know, if you sub it in, it will be 0. So, just like the bowling tactic, let's, you know, he's protected by too many of his friends. Let's isolate the K, and then, you know, and then go for the prize. So, 12 I don't really need, so I'm going to move that over. So I'm going to just expand it first. 12 plus 6K plus 8 plus K squared plus 6K equals to 0. Okay, so then now I'm going to move. Wait, do I want quadratic? Actually, this might be a nice quadratic. Let's see. I don't want to use quadratic formula. That would be a nightmare, but you know, it might be able. I'm pretty sure you can factor this. But let's see. Okay, so 12 plus 8, that's going to be 20. I'm writing here because I want like x squared plus x plus whatever, or you know, the quadratic format, right? So 12 plus 8 is 20, and then 6K plus 6K is going to be 12K. Okay, that looks promising. And then there's only 1K squared. Let's just make sure. 12, 8, I use those to 6K. Yeah. So that's pretty legit. So how do I factor this? Okay, good thing is there's no coefficient here, so it's going to be just KK. Something times something gives you 20, but if you add them together, it's 12. What could it be? Oh, well, you can play with this. Like, for example, if it's 6, if you do like 5, 4, yeah, it gives you 20 as a product, but if you add 5 plus 4, it's going to be like 9, which has nothing to do with this. So, ooh, food is ready. Okay. So anyways, concentrate. Okay, so that's going to be 10, and that's going to be 2, because if you 10 times 2, 20, add them together, you're going to get 12. So, yeah, that's that. So, essentially, there are two possibilities, both of them work. So it's going to be K equals 2, not 10 and 2, negative 10 and negative 2. because if you put 10 here, it's going to be 20, right? So just no rookie mistake at this point, right? So negative 10 plus 10, it will be 0. So everyone got that idea. So that's question 3. Okay, so this is question 4. Find the matrix A in this expression. If the whole expression 2i plus 3a to the power negative 1 equals to this matrix, right? So basically, yeah, very similar to the question we've done already, but we all know the one way to get rid of the exponent is exponent negative 1 is to do another exponent of negative 1. I was hoping for questions where there was a negative 1 and transpose on, but I guess that didn't quite happen. That would have been interesting. But nonetheless, that's what we do, right? So there is there's 2 ways to do inverse so far, right? So if this was this, then technically we could just be doing, right? You put the identity matrix on the right and on the left. This is section 1.5, which I haven't covered quite yet, but my apologies for that. Some of the tests, I think 1.5 was on a test. My understanding was that it was between 1.1 to 1.4, but nonetheless, it's the same idea, right? Inverse, right? That we learned in 1.3 or 1.4, right? So essentially, you're just making this side become identity, and then whatever this becomes, that is your inverse. So how does that, that's going to be covered in 1.5. But nonetheless, if it's 2 by 2, usually we just want to use this formula. So 1 over determinant, and then open matrix. A and D are switched, B and C are staying in the same place, but they have negative signs instead. So determinant is AD minus BC, and that's small a, not big A, because if that's big A, that means it's matrix, which is not the case. These are entries only. So what I'm gonna do is I'm gonna get this whole thing, and then put it as negative 2, and put it as an inverse, and I'm gonna put inverse on the same thing on the right, right? So if I do that, then this is gonna be 2i plus 3a, because this inverse and inverse will cancel each other out, and then the inverse of that matrix is we use that 2 by 2 inverse formula. 1 over AD, which is 5, minus BC, which is 2, 3, so that's going to be negative 6, minus 6, and then it's going to be 5, 1, they switch, 2, 3, they don't switch, but they just switch the sign. So I have that, okay? So let's simplify that a little bit. So that's going to be just 1 over negative 1, right? So that's going to be just negative 5, 2, 3, negative 1. And that's going to equal all to 2i plus 3a. Okay, so again, just like bowling, our target is A, right? So let's remove anything that is not related to A as much as possible. Let's get rid of I. So that's going to be 3a equals 2, negative 5, 2, 3, negative 1, minus 2i, right? That's 2i, right? But we do know what I is though, right? I is just the identity matrix. So if it's 2 by 2, the identity matrix must be 1, 0, 0, 1. So that we mentioned that when we were discussing about how another method as to how to find an inverse. But it's times 2, right? So it's times 2 here. So I'm actually going to get rid of that. And then just do the times right away. 2, 0, 0, 2. So same thing, it's 1, 0, 0, 1, but I just times it by 2. So 0 stay the same because anything times 0 is 0, right? So that's what I'm going to do. It's a pretty straightforward subtraction matrix. So that's going to equal, I'm just going to write it on the side. That's going to equal 2. Negative 5 minus 2 is negative 7. 2 minus 0 is just 2. 3 minus 0 is just 3. Negative 1 minus negative 2 is negative 3. We're not quite done yet, because that equals to 3a, right? So we want a. So what I'm gonna do is just divide this by 3, divide this whole thing by 3. Don't do this though, right? Don't do this. If I was I probably wouldn't mind, but just do it this way, times 1 over 3, right? Because if you don't want to bring division directly to the matrix itself. So, anyways, but we both understand what we're getting at. So we're gonna have a because 3 divided 3 cancels out, and It's going to equal to 1 over 3, negative 7, 2, 3, negative 3. So that's going to be just divide everything by 3. 1, negative 1. There you go. And that's all there is. Yeah. And this person did exactly that. So, yeah, good job. So, yeah, so that's all there is. And the last question will be numero 5. If A is invertible matrix, oh yeah, this was one of the last question in 1.4. I still remember it. But yeah, this will, yeah. So if A is invertible matrix, and AB equals BC, no, AC, yeah. C, prove that B equals C. Okay, well, let's try to figure out what that means. A, B, A, C. Okay, so A is inversible, which means there is inverse. So really simple. So here is asking, prove that this is B equals C. Stop if you're looking for a solution. I'm going to talk about it right now. Anyways, okay, so anyways, I'm just assuming you paused and you did all your stuff. So anyway, so we have A, B equals AC, B equals C, prove it. If A has an inverse, right? That's really simple. You just say, well, if this exists, right? Because that's what it says, A is invertible. This is the inverse version of A. I'm just going to times it on both sides. It is important that you put this in the right order, right? Because you can't squeeze in between. Because remember, when you multiply, the dimension and the order matters, right? So, anyways, but because we put both in the first, we put inverse A in front of both expressions, so it's equal, right? So A inverse times A, that's identity matrix. Again, that's, oh, I keep doing that. That's not B, that's C. I C, right? Okay. So this is one minor thing. I guess, this person didn't make a mistake. I sort of did. I didn't lose mark for it. But nonetheless, you don't just say I and I will cancel out. Because remember, we can't really divide the matrix, right? So don't do crossing out. I don't think you'll lose marks because, it's a minor thing. But, so basically all you do is, okay, well, identity is just times 1. So it doesn't matter, right? So we all know, so we're just going to say B equals to C. That's all there is. Very simple stuff, right? Okay, so this is 5B. We're doing exactly what we've been doing in 5A. The only difference though is that A is not invertible, right? So we can't use the same trick because we can't use A to the power of -1, right? So what our goal is, we're still trying to prove that A, B, and AC are equal, but B and C are not necessarily equal. Otherwise it's too easy, right? Exactly. So yeah, and they gave us the A this time, right? So it's 1, 1, 0, 0. So so we just have to come up with B and C so that if we fit into this 2 equation, it will be true for both cases, right? So again, as I've said in 1.5, try to make sure the matrix is as simple and as close to identity matrix as possible, right? So use 1s and 0s. They are your friends. 2 maybe, but anything more than that, it's now you're just asking for algebraic mistakes, right? So try to keep the numbers simple. So this person used 0, 1, 1, 0, right? Works. And C equals to 0, 0, 1, 1. Again, see, this is very simple. So when you multiply, you're not going to have issues. It doesn't have to be these 2. You could choose anything else. I could have chose, if I wanted to, I could have chose this, right? Just don't choose anything that's an eyesore, don't make it all 0, because that's 0 times 0. I suppose you could do it, but it's in a bad taste, I think. So, you can ask your prof, if you can, that would be awesome, because that's the easiest way, right? Anything times by 0 is 0, so. But anyway, let's just assume that you come up with a simple matrix like this one, right? So let's see if it works. Chances are, it's gonna fall into this. There may be a possible scenario where both, where whatever you put in may not equal, right? It just means try again. There's so many examples, right? Statistically, you're bound to get 1, right? Almost on the first try. But anyway, So I'm gonna do A and B, so that's gonna be 1, 1, 0, 0, and this is gonna be 0, 1, 1, 0 equals 2, 1, 1, 0, 0, which is the same A. I'm gonna put C here, 0, 0, 1, 1. Okay, let's give that a shot, okay? So yeah, let's see. So I'm going to do that. So it's going to be 1. Okay, so this is question 5b. Almost exactly same as question 5a, which we just done. But the only difference is a minus can't be invertible. So we can't pull the same trick because we can't use the a to the power of -1. A inverse does not exist, right? So so basically our goal is try to make sure that AB still equals to AC, but B and C are not necessarily equal, right? So I mean, if B and C can equal, then it's, you know, that's in a bad taste, right? I mean, that's too easy, right? So yeah, so we have to come up with B and C matrix, and then hopefully they will satisfy both of these conditions. So how do we choose B and C? Technically speaking, you know, statistically it's on your side because there are a few exceptions, but they're very, very hard to get, right? So, I mean, fluke is that you're gonna get one that doesn't work. Almost all the cases it will work. Sometimes you can make things a little easier though. Like for example, the common sense is when you do use your matrices, please use a simple number, right? 1s and 0s are your friend. 2s, okay, maybe. Anything more than that is like, okay, seriously, why, right? So, so yeah, so this person did 0, 1, 1, 0, 0, 0, 1, 1. You know, so these are simple numbers, pretty similar to identity matrix as a matter of fact. So make your job a lot easier by choosing these simple matrices, right? Another thing that would really help you, if you notice it, when they give you an A is 1, 1, 0, 0, right? So whatever your times it with row 2, it's gonna be 0 no matter what, right? So bottom row is all 0. So product of AB or AC will have all zeros at the bottom, which makes sense, right? What do I mean by that is because let's say here, right? If I have 0, 0, and then I have, they can sort of see it. Okay, we already know we're gonna prove this, so we're gonna erase that. So, like let's say if it was 1, 1, 0, 0, right? I don't know what this is, right? But see, first one, second one, right? So I'm gonna have some kind of number here because it's like 1 and 1, right? But when I use second row to times it, anything at the bottom will become 0. Okay, this will be some number, this will be 0, right? So, you know, so that can help you to predict things a little easier, right? But again, ultimately, it shouldn't really matter, right? I mean, it's nice that you notice, but you know. But anyway, so I'm just gonna stick with what the entries he's got. But honestly, it could be anything. It could be, I don't know, it could be this if you wanted to, or it could be this. Okay, maybe put it a little bit more simpler than that. But you get the idea, right? So, anyways, so if we do that, then we just do this: A times B, A times C. That's gonna be 0, 1, 1, 0. And anything at the bottom 0. Ah, interesting. So that's gonna be 1. That's gonna be 1, 0, 0, 0, 0. They equal. So A, B, B, C works. But is B, C equal to C? They are not. Therefore, it fulfills both of the conditions. So it's that easy, folks. I could try to algebraically figure out where the exceptions are, but you know, unless you're planning to take linear algebra too, I say don't worry about it so much, okay? I mean, the fact that you appreciate this is good enough as it is. So that covers test 1. This is the first quiz issued by I really need to remember his name, the Indian guy, right? Next video, which is gonna be quiz 1. Part B, I guess, that's how I name it. This will be the quiz that my professor covered through. Looks a little simpler than this, but we also have a 3x3 matrix, and we have to do inverse. So that's a little complicated, and you have to check. I actually spent most of my time working on that question. So, but anywho, so yeah, well, we'll get right on to part B, and we'll see you there if you'd like to see the video then. Yeah, and I will be posting 1.5, 1.6 over the weekend. 1.8 if I have time, but we'll see how that goes. Trying to keep up, so to speak. But anyway, yeah. But anyways, for new students who have yet to take the quiz, hopefully this will give you some warm-up exercise, so that when you get the quiz, you will feel a lot more confident than us. Yeah. So that's that. Yeah. We'll see you in the next quiz or next section, depending on what you're into.